Okay, one last question before we go back to, or before we go on to inequalities. So right here with a literal equation, there are just multiple variables is all it means. And we're trying to simplify and solve this for r. So that means you have to cancel out everything with the r. So since I'm multiplying everything, I just have to divide by the 2 pi. And if I do it on one side, we have to do it on the other. So we end up with r equals c over 2 pi. So same type of thing over here. So we've got pi and h are in the way, so divide by pi h on both sides. So v over pi h equals 1/3 r squared. And right here, in order to get rid of this 1/3, we multiply by 3, because that is the reciprocal of this. So now we have 3v over pi h is r squared. And now we're to the last step. How do we undo squaring? Well, we simply square root both sides, leaving us with r equals the square root of the fraction in our next to last step. Alright, so let's give these inequalities a little bit of a practice. So we've got that 7 is greater than or equal to p. Now, not that it's impossible to do this, but a lot of students find that it's just a whole lot better if we take and flip the entire inequality so that we can use the words less than and greater than to figure this out. So we've got -7 is going to be the focus number, and then we just need some number bigger and some number smaller. Now, p is less than or equal to -7, so the equal to means we have a solid dot, which I will do to the best of my ability. And then we have that p is less than, so all the numbers less than -7 run to the left in our drawing. And that would be that picture. So solid dot, less than is to the left. Over here on example 10 though, we have that 3 is our focus. The letter does not matter. I just usually go with X. Now the shading is to the right, or if we see this 8, 8 is bigger than 3, so therefore X is greater than the 3. Alright, so let's translate a few word problems. Jeff needs at least $21. So let's see here. So we're going to have Jeff and we're going to have $21. Now he needs at least, which means he's going to have more than $21, it sounds like. If he needs to go on the trip, he's going to need more than 21 potentially. But we also need to consider, what if he gets exactly $21? Would that still work? And the answer to that is yes. Yes, it would. So in this case, it would be greater than or equal to. But over on 16, we've got students, and then we've got 32. And we need fewer than 32. So fewer, of course, less than. And now I have to ask myself, would 32 be fewer than 32? And the answer to that's no. So therefore, no equal to on that particular problem. All right, so we're coming back and we're going to do solutions to inequalities. So here on example 17, just like in previous ones, we got to eliminate this constant term. So we're going to add 7 on both sides. So we're left with 21 is less than negative 3x. And that negative 3 is joined to the x by multiplication. So we're going to divide. So finally, we're going to have negative 7 and the x, but notice I haven't done the inequality because on this previous step we divided by a negative, and as many times as we talked about it, when you divide by a negative it switches the sign. And then just for our own sanity, we're going to flip the entire thing just so it makes it a whole lot easier to graph this. So negative 7, we have an empty dot because there's no equal to on this. And then less than would be to the left side for our shading or your squiggle, whichever way you choose to view that. Alright, now getting into some compound inequalities, and there are two that we have to deal with. You've got the one on the left in example 18, which is a and the way we see this is we got this constant 12, so we need to add 12, but now I'm no longer saying to both sides because notice there are 1, 2, 3 pieces to this, so whatever you do to one piece you have to do to all pieces. So we have negative 21 is going to be less than or equal to negative 7n, which is less than negative 14. So the negative 7's got to go, and whatever we do to this one piece we've got to do to all pieces. And that gives us 3 n and 2. Notice I didn't write the inequalities this time either because again on that next to last step we divided by a negative. They have to flip. So in this case our answer is that n is between 2 and 3. But 2 gets an open dot, 3 gets a closed dot, and then because this was an and, most of the time it's going to be a squiggle or shade in between. Alright, up on example 19. I'm going to add 7 to both sides. Oh, sorry, not add 7. I'm going to subtract 7 from both sides. End up with negative 5b less than negative 15, which then we divide by the negative 5 on both sides and end up with h is greater than 3 because again divided by a negative we had to flip. On the other original problem, minus 9 from both sides. 2b is less than negative 2. Divide by 2 on both sides. B is going to be less than 1, negative 1. So negative 1s are lower, 3s are upper. Both are without equal to, so that's going to be open dots on both. And this being an or, although looking at this, less than -1. And the other one would be greater than 3. So the first one shades inwards, the second one shades outwards. And final problem for the review. The question that's going to happen on the test here is going to be what step yields step whatever. So, for example, step 1, that's given. Step 2, how did we get step 2? Well, step 2, the parentheses disappeared. So what step yields step 2, or what property yields step 2? That'd be the distributive property. So you're just simply stating, how did we get it? So how did we get 2? Distributive property. How did we get 3? Well, the 15 and the 5 somehow changed into a 10, which tells me that we combined like terms. From step 3 to step 4, somehow that 50 disappeared. So how did we make it disappear? Well, we had to do the inverse operation, which was add 50 to both sides. So that tells us that we had the addition property of equality. And then finally, how did we get the 10 to disappear? Well, we did the inverse of that as well. We divided by 10. So that results from the division property of equality. So on those 1 or 2 test questions like this, you're just going to have to tell me what you did to get that last step. So there's all the review, guys. Good luck, and hopefully you do well on the test.